Greetings, everyone. Welcome back to another Math 104 lecture. Today, what we will be discussing is quadratic equations. Now, we've already mentioned in some of the previous lectures quadratics. Quadratics are going to be in the form of ax squared plus bx plus c. For them to be an equation, though, that means obviously an equation implies there's going to be an equal sign. So a quadratic equation is just going to be the top piece here, which I will box off. So we have ax squared plus bx plus c is equal to 0. Now, keep in mind, this is in standard form. Standard form it's standard because the right-hand side, or one of the sides, is equal to 0. So one of the sides has to be 0. The left-hand side just have to have its highest power of the polynomial being an x squared. So the highest power is going to be a 2. That's what makes it a quadratic. Keep in mind, we just recently talked about linear equations and how those were first order equations. And what made it a first order equation is the power of the x, right? The power of the x was a 1. So it was a first order. A quadratic is a second order equation. Okay. There is the little caveat here that so our coefficient of x squared cannot be 0. And this should make sense, right? Because if a is 0, then there is no x squared, because 0 times any number will make it 0. So then all we're left with, and I'm just going to hypothetically put some red lines here, all we're left with is just the bx plus c, and you say to yourself, oh yeah, duh, that's just a linear equation, right? That's just a first order equation because our highest power of x would be 1. So clearly we can't have a equal to 0 in this case. Okay. All right, so before we actually move on to how to solve anything, we need to know one very, very, very important property, and that's called the zero product property. The zero product property is actually what allows us to solve the grand majority of quadratics that you will be encountering. So the zero product property says if you have two numbers being multiplied, so a and b, and it equals 0, then a and b equals 0 if and only if. That's what the IFF means, if and only if. And I'll explain that in a second. If and only if a is equal to 0, b is equal to 0, or both a and b are equal to 0, right? And that should make sense, right? Because again, as I just said earlier, why a can't be 0 in the standard form over here. It's because anything times 0 is equal to 0, right? So if we're talking specifically about any two numbers here and they're being multiplied, then for our result to be 0, at least one of them has to be 0 as well, right? So what this allows us to do is it allows us to kind of hunt for which factor is actually 0 and which one isn't, or so on and so forth. So our zero product property allows us to go ahead and split up our factors as long as they are equal to 0. And that's why our standard form on one of the sides is equal to 0. Because when we go through our methodology for solving, what we will be doing is eventually we're going to get two different linear equations that we're going to be solving. Okay, I know that was a mouthful. I know it doesn't make sense just immediately from me talking about it. So let's look at an example together and it'll start clicking, okay? So let's look at our first example here. And the first example is we're going to solve for x, okay? So our equation is as follows. We have 2x squared plus 7x minus 4 is equal to 0. And I'm just going to draw a line because this is where we're starting. Now, before I continue, I want to also mention this. I'm posting this lecture, and then there's going to be another lecture going into Friday. They're both going to be on quadratic equations. The reason is that there's actually 4 different ways that you can solve a quadratic equation. Some of them, you can't use all the time. Some of them you can, and I really want to make sure that we're as precise as we can as far as understanding the methodologies behind them, right? So what I'm going to do is I'm going to essentially do 2 and 2. So today we're going to focus on 2 methods, and then in the next lecture we'll focus on the remaining 2 methods. The 2 for today are fairly intuitive, especially because one of them you've already been doing. And then the 2 going into the next lecture might not be as easy. So it's really good to get a strong foundation here, and then when we move into the next one, those might seem a little bit easier, based off of what we've done here today. So the first method of solving a quadratic equation is simply by factoring. And we've been doing a whole bunch of factoring. That's what all of the fourth lecture was about. If I and the both of the homeworks attached to the fourth lecture. So we know how to factor. So this should be pretty pretty comfortable here. So what do? Well, we kind of go ahead and ignore the fact that this is an equation at first. Just think about it as just the quadratic, right? We're just talking about the polynomial because we're not going to try to factor 0. Right? It's already in its standard form. We have a 0 on one of the sides. If we didn't, we would have to move that number over so that way we did have 0 on one of the sides. But right now, it's in standard form. So to factor, what we do is we say, okay, well, there's a coefficient to the x squared and it's not 1. So we have to do that secret step, right? So we have to do the a times c step. And our a is going to be the coefficient of x squared, so that's 2. Our c is going to be the constant, right? So in this case, it's going to be -4. And we know that 2 times -4 is going to give us a -8. And that's important that we know that it's a negative because the factor pairs that we're looking for, the signs are going to be flipped, right? Because we need a positive number and a negative number multiplied together to give us a -8. So we list the factor pairs here. We say, okay, there is plus or minus 4, and then the sign is going to be flipped, right? So minus or plus 2. And then the other factor pair is plus or minus 8, and then minus or plus 1, right? Okay, so now our goal here is we have to check our factor pairs and see which one of our factor pairs adds together to give us the 7x, right? Or 7. Just again, we're concerning ourselves with the number here. So we say to ourselves, okay, are 4 and 2 ever going to give us 7? No, right? Because they're even numbers. So whether you add or subtract them, it's still going to be an even number. You can't get 7. So these guys totally out. Doesn't matter what the sign is. Then we say, okay, 8 and 1. Well, yeah, definitely, right? If we have a positive 8 and we have a -1, right? We need one of the signs to be negative. Then they would multiply together to give us a -8. However, when we add them, so 8 plus -1, that's the same thing as 8 minus 1, which is 7. Hooray! Check mark, right? That's exactly what we're looking for. We're looking for the positive 7. So now we can split this up into our two factors. So we have 2x squared, right? And we're going to split it up into our factors, which are plus 8x and minus x. And then we just bring down the -4, right? The entire idea here is we're just bringing down the pieces that we haven't touched, right? We didn't touch the 2x squared. We didn't touch the -4. Now, this is really the important piece that I want you guys to remember. Please make sure you continue to carry down the equal 0. The reason for this is because you're not working with an expression, you're working with an equation, right? And for there to be an equation, you need to have one side equals another side, right? So continue to bring down your equal 0 every single step that you do something. Okay, well, you guys know this part, right? This part's pretty easy. What we're going to do now is we're just going to go ahead and start grouping, right? So to start grouping, we do that, we do this, right? And I'm just going to put a plus sign here because we had a -x, but it's the addition of, a negative number, right? So it's essentially, I can just put a plus sign in between. Okay, so now what we do with the first parentheses, you guys already know this. We look for the factor that we can break out of this. So the largest factor that we can take out of both is going to be a 2x. So we take 2x out, and we are left with x plus 4, right? Okay, perfect. So we're left with x plus 4. And now that should be your clue, right? Because again, when we're doing the factoring by grouping, you're always trying to find whatever is in your parentheses should match the other side of whatever is in your parentheses, right? So we're hoping to get an x plus 4. Right now, we have a -x and a -4. So if I pull out a -1, which is exactly what I'm going to do, I'm going to pull out a -1 from both, then that's just going to flip the sign, right? I'm taking out the negative. So if I take out the negative from -x, I'm left with a positive x. Take out the negative from the -4, I'm now left with the positive 4, right? So we have the 2x times an x plus 4 and a -1 times the x plus 4, still equal to 0. Okay, well, once again, we already know how to do this. We're just doing the distributive property, but in reverse, right? We're taking out the piece that's being multiplied against both. So we are going to go ahead and take out the x plus 4. So taking out the x plus 4 from both sides, or I'm sorry, from both pieces, we're left with 2x minus 1. And now it's equal to 0. And now we say, hooray, we have it factored, right? So that was the hardest part. Now, using the zero product property, right? The zero product property says that if we have two pieces, two things being multiplied together, doesn't matter what those things are. It could be, just regular numbers. It could be two expressions. As long as we have two things that are being multiplied together and they equal zero, then at least one of them is going to be zero, or possibly both. So this is what we're going to do. We're going to split this up into each of their own equations, such that each factor is equal to zero. So by doing so, we're going to say, okay, we're going to have x plus 4 is equal to 0 over here, and we're going to have 2x minus 1 is equal to 0 over here. And now you see that both of these are just linear equations, right? Our first order equations, x is only to the power of 1 because we've successfully factored the x squared, right? We broke it up into two different x's being multiplied against each other. So we have two different linear equations that we have to solve. And they're fairly straightforward, right? X plus 4, to solve for x, we're just going to subtract 4 from both sides. We get x is equal to negative 4. And then on the right-hand side, before we can do any sort of division, we're going to add the 1 over. So we have 2x is equal to 1. And now we divide both sides by 2, and we get x is equal to 1/2. And now you see we have two solutions for x. We have x is equal to negative 4, and we have x is equal to 1/2. And at the end of the day, what we do is we write it in this following format. X is equal to, and you can put a curly brace, and you put your two answers side by side separated by a comma and another curly brace. And what this is this is called the solution set for our equation. And what does that mean? It means it's the set of all our solutions, right? If you're going way, way back to the first lecture and we talked a little bit about sets back then, right? We remember we had something in the form of like if we had A, and then we had A, B, C, dot, 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 right, as our elements. It's the same exact idea, right? We're just saying that we have a set of solutions and all of the set of solutions are contained in our curly braces. So in this case, negative 4.5. Those are our answers. Those are the only two numbers that we care about, okay? So that would be your final answer. And now it's good practice to go ahead and check just for the sake of checking, because you want to make sure that your answers are, of course, correct, right? And that it makes sense. So our original equation was 2x squared plus 7x minus 4 is equal to 0. So what we're going to do is we're going to plug each of the individual answers in that we got, and we're going to check them just to make sure that they work out, right? So we're going to do a half first, and doing 1/2 first, and I'll write a check here just so no one gets confused. So writing a half first, we have 2 times 1/2 squared plus 7 times 1/2 minus 4 is equal to 0. Okay, so 1/2 squared, what you do is you apply the exponent to both the numerator and the denominator. Applying it to the numerator, 1 squared is still just 1. 2 squared in the denominator is going to give us 4, right? So we get 2 times 1/4. And we get 7 times 1/2, which is just 7/2. And I'm going to go ahead and just, because I know that this is going to be in terms of a half, I'm going to change the minus 4 to be in terms of halves as well. So minus 4 is the same thing as minus 8 over 2, right? 8 over 2 is the same thing as 4. So I just made it into a fraction with the denominator that I wanted it to be. Okay, so now we get 2/4 plus 7/2 minus 8/2 is equal to 0. 2/4 is the same thing as 1/2. 1/2 plus 7/2 is 8/2 minus 8/2 is equal to 0. And yay, that works out, right? 8/2 minus 8/2 is equal to 0. Great, we're done. Okay, so that was one check. And for the other one, we have 2 times, and again, I'll draw a line here just separating them, 2 times negative 4 squared plus 7 times negative 4 minus 4 is equal to 0. Okay, so negative 4 squared is the same thing as 4 squared, which is just 16. So 2 times 16 plus 7 times negative 4, which is going to give us a negative number, right? So negative 28 minus 4 is equal to 0. 2 times 16 is 32 minus 28. And so we have a negative 28 minus 4. That's the same thing as minus 32, right? And 32 minus 32 is 0. Yay, we did that one too. So both of our answers check out. We know that the check is correct. Hence, we know that our final answer, our solution set of -4 and 1/2 is correct. So this would be our final answer here. Okay. All right. So let's go ahead and do our next example here. I think this is a good point for you guys to try your hand at the first classwork assignment. So go ahead and give it a shot. The first classwork assignment is x is equal to x squared minus 12. Okay, so give this a shot, see what you come up with. Hopefully it's not too bad. Okay, so hopefully this was pretty okay for you guys. Again, we're just going by factoring, right? Our first method that we're learning today is factoring. So to factor this, before you can do anything with factoring, what you need to do is you need to get it into standard form, right? And standard form means that you have a 0 on one side of the equation. So the easiest way to do it is I'm just going to subtract x from both sides. So subtracting x from both sides, we get 0 is equal to x squared minus x minus 12, right? Okay, so our coefficient of x squared is just 1, so we don't have to do that secret step of a times c. So we just have to look at the factors of -12. So over here we say, okay, -12. What are our factors? So we look at the factor pairs. Again, the signs are going to have to be flipped because we have a -12. So we say, okay, we have a 12 plus or minus 12 minus plus 1. We have a plus or minus 6 minus plus 2, and then plus or minus 4 minus plus 3, right? Okay, so off the bat, you can say, well, there's no way that's going to work, right? Because we're trying to get a -1. We're trying to get the -1 is coming from that middle term, -x, and when there's no number there, you always know that it's a 1, right? So -1 is what we're hoping for this to add up to. Okay, so that's obviously going to be out. Then we say, okay, 6 and 2. Is there any way that this is going to give us a -1? You say no, right? You try the combinations. And then last but not least, you say 4 and 3, and you're like, oh yeah, -4 plus 3 gives us a -1, right? So we wanted this guy and we wanted this guy here, right? -4, positive 3. And that's what we are going to write this up as, right? So we split them up into our two parentheses. We have x minus 4, x plus 3. And now we do the same thing that we did before, right? It's factored, it's part of an equation, and it's equal to 0. Those are our three, that's our checklist, right? If it's factored, it's part of an equation, and it's equal to 0, then we're good to go for that 0 product rule, which means that we can go ahead and we can split this up into x minus 4 is equal to 0, and also x plus 3 is equal to 0. I know you guys know how to solve this, right? We just add 4 to both sides, x is equal to 4, and in the other equation, we subtract 3 from both sides, x is equal to -3, right? Okay, so that's it, and now we write our final solution set as -3, 4, just separated by a comma. Those are the only two numbers that we care about. Those are our only two solutions. And the only reason that I write the -3 first is just out of practice. I write the least value first. It's totally fine if you write 4, -3. I'm just, in the habit, in the practice of writing the lowest number first. Okay, so again, feel free to go ahead and check this. I'm going to move forward without checking this, but again, it's good practice to do so just to make sure that your numbers worked out. And the process of checking it is just taking your two different numbers, plugging them in one at a time into your original equation. Okay, keyword here is original equation. Before you do anything else, before you did any kind of manipulation, you want to plug it into your very first original value. The reason is because if you made a mistake somewhere along the lines in, your steps, right? So we went from here to here, then we went from here to here, right? If you had made a mistake at some point there and you plugged it in at the wrong place, then you might be in a logical conundrum, right? You might end up proving that your wrong answer is correct because you plugged it in, too far down after you've already made the mistake. So plug it into your very first original equation, and that way you know that your check is accurate. Okay, so I'm going to go ahead and clear the page, and we will go ahead and move on here. So let's go ahead and do another example here. The two lectures between this one and the one going to Friday are going to be very example intensive. So we'll do another example here. Say we have 2x squared plus 32 is equal to 16x. Okay, so our idea here is the same as before, right? We want a factor. That's the only method that we know right now, and we want to get this into the standard form, right? So to get it into standard form, we need a 0 on one of the sides. We're going to subtract that 16x over, right? That's our very first step, get it into standard form. So we have 2x squared plus, 2x squared minus 16x plus 32, because again, we subtracted 16x from both sides, and that's now equal to 0. And now we say to ourselves, okay, well, we don't know anything better yet, right? So what we do know is because we have a coefficient for our x squared, we do have to do that a times c step. So a times c in this case is going to be 2 times 32, which gives us 64. And now we're looking at factors of 64 such that it will give us, when added together, a negative 16, right? And hopefully you guys can just get to it. I'm not going to list out all of the factors, but hopefully you guys can get to the point that you say, oh, 64 is a perfect square. So 8 and 8 are going to be factors, right? Which means that -8 and -8 are also going to be factors, and those ones should work out, right? So -8 plus a -8 would give us our -16 as desired, right? That's what we're looking for. So again, I just jumped the gun on listing out all of the factor pairs, but eventually you'd get there. So at the -8 twice. So that's exactly what we're going to write down, right? So we're going to put the 2x squared minus 8x minus another 8x plus 32 is equal to 0. Okay, now we do our grouping step, right? So grouping, we're going to do this. We're going to put a little plus sign there, and we're going to keep the negative with the -8x. And we're going to say, okay, we're going to pull out the 2x from both the 2x squared and the minus 8x. So we do so. We are left with x minus 4, right? Okay, so again, x minus 4. That's what we're hoping to get here. So right now, in the other parentheses, we have a coefficient of -8. So what we should try to do is we should try to take out that -8 if possible, because if we can take out that -8, then that means that we can just have our x, and by taking out a negative of a positive 32, we're going to end up with a negative number, right? So we take out a -8, we're left with just x, and then taking out -8 of 32, we're left with a -4, which is perfect. That's exactly what we're looking for, because we, again, want these two pieces to match, right? And this is still equal to 0. Okay, we finish up our grouping step, which is the distributive property in reverse. We pull out that x minus 4, so x minus 4, and then what do we have left except just the 2x minus 8 is equal to 0. Okay, and now again, by the zero product property, we can go ahead and split them up. We have x minus 4 is equal to 0, and 2x minus 8 is equal to 0. And we solve for this. We get x is equal to 4, and over here we have 2x is equal to 8, because I added 8 to both sides, and then divided by 2, we get x is equal to 4. And you say, wait a second, hold on. I have x is equal to 4 twice. What is this telling us? What does this mean? Well, what this is essentially telling you is that you have the same solution twice. You have one, technically you still have two solutions, but it's only at one particular value. And this gets into a topic called multiplicity. Multiplicity essentially is if you have a solution with multiple iterations of itself, right? If it repeats, then it has a multiplicity of that many repetitions. So x is equal to 4, being our solution, has a multiplicity of 2, because it has repeated itself twice, right? We have x is equal to 4 on the left side, x is equal to 4 on the right side. And if, say, for example, we were dealing with a cubic and, we essentially factored it down, we solved for it, and we got x is equal to 4 3 times, then it would have a multiplicity of 3. Okay, so multiplicity, and I'll write out the word, that is what's occurring here. Multiplicity. Okay, so that's a topic that is kind of important for quadratics, but way more important for what is coming up in the next couple chapters. So because with quadratics, we're only going to have a max of 2 solutions. Why? Because we only have a highest power of 2. You can only have the number of solutions at maximum as your highest power in the polynomial. That's why when we were doing linear equations, and I posed this question for you guys to keep in mind how many solutions you're getting for a linear equation, how many solutions you guys are getting for a quadratic. That's why when we were getting the linear solution, the linear equation solutions, we were only getting 1 per linear equation, and that's because the first order equation has a max exponent of just 1. Okay, but this isn't the whole story. I don't want to just emphasize multiplicity here. I also want to emphasize something else. There is a slightly easier way to do this. So let's go all the way back up here, and I'm going to erase what's on the right-hand side where we did that A times C business, right? So let's box this off because this work is all technically correct, but it's still a little bit more difficult than we really needed it to be. And what do I mean by that? Well, let's say that we still get into standard form, right? So we get the 2x squared minus 16x plus 32 is equal to 0, right? It's in standard form because one of the sides is equal to 0. And that's a 0, not a 6 or a g or something. Wow, that came out even worse. You know what? That's fine. 0. That's close enough. Okay, so what we can do at this point is we can actually divide out a factor of 2. Why can we do that? Because the factor of 2 isn't going to influence our solutions. It's the same thing as if we factored out 2. So if I pull out 2, and if I pull out 2, we have x squared minus 16x plus 30. I'm sorry. Whoa, I did not factor out the 2 from those guys. I was just going on autopilot there. My mistake. If we factor out 2 from everything, minus 8x plus 16 is equal to 0, right? And what does the zero product property tell us? Well, we have one thing here times another whole thing here is equal to 0, right? So eventually, even after we factor x squared minus 8x plus 16, we get other factors there. Eventually, we're going to have 3 factors where one of them is 2. Right? And we would do the zero product property where we eventually set 2 is equal to 0. And that's absolutely nonsense, right? That means nothing to us. So what we can do earlier on in the process is we can just divide out by 2. I'm just going to divide everything here by 2. So divide by 2, divide by 2, divide by 2. And whatever I do to the left side, I also have to do to the right side, correct? So divide by 2. We get x squared minus 8x plus 16, and 0 divided by 2 is still just 0, right? Well, now this is significantly easier to work with because our coefficient of x squared is now just 1, which means we don't have to do any extra first step, right? We just have to look at factors of 16. And when we look at factors of 16, we say, okay, we have positive 16. We need 2 negative numbers, right? Because we need it to add up to be negative 8. So we come up with negative 4 and negative 4. And so we have x minus 4 times x minus 4 is equal to 0. And then we do the zero product property all over again, where we have x is equal to 4 twice, right? Because we split it up into x minus 4 is equal to 0, x minus 4 is equal to 0. And when we solve, we get x minus 4 twice. I'm sorry, x is equal to 4 twice. And so we say, oh, wait, we look at these factors and we say, oh, yeah, we have the x minus 4 here, but we have the 2x minus 8, right? Well, hidden inside of the 2x minus 8, if you were to divide out the 2 from everything, right? If you divide out the 2 from the 2x, if you divide out the 2 from the 8, and you divide out the 2 from the 0, you still just end up with x minus 4 is equal to 0. And we end up with the same solution either way. So what I'm telling you guys to do is if you have a quadratic equation, okay, you cannot do this if you just have an expression that you're factoring, okay? Keep that in mind. But if you have a quadratic equation where you can divide both sides by a particular number that goes through every other number, right? It goes, our 2 went into each possible number evenly, We didn't end up with some fraction. We didn't end up with some, like decimal garbage, right? We got, it went into it evenly. Then by all means, take that opportunity to make it easier for yourselves. Divide out by the 2, because then we just end up with an x squared minus 8x plus 16, and that's way more friendly than 2x squared minus 16x plus 32, trying to factor those, right? Either way, you will end up at the same conclusion that the solution set of x is just 4. And for the record, I just want to take this opportunity to say, when you have a number, when you have a solution with a multiplicity of 2 or higher, just write it one time, right? You only write it once. So x is equal to the solution set of it being 4. And this would be our final answer here. And same thing over here, we would write x is equal to solution set of 4. Okay, so hopefully all that makes sense. And that we can now go ahead and move on here. So it's been about 30 minutes. We're going to go ahead and discuss the next topic, and hopefully that will be it for today. So moving on, we can now go ahead, and there's a different way that we can solve quadratics. And the other way that we can solve quadratics is by considering squares or perfect squares. Now, what I want you guys to recall is difference of squares, right? Hammering this into you guys. A squared minus b squared, everybody should know this at this point, right? Gives us a minus b times a plus b, right? Okay, so if I tell you guys for, hypothetically, right, just here's an example. I want you guys to solve for x squared minus 4 is equal to 0. You say, oh, that's super easy, Hassan. This is, super easy to work with. X squared minus 4, this is a difference of squares, right? Because 4 is a square. X squared is a square, and we have a difference of the 2, right? So you could easily tell me this is x plus 2. X times x minus 2 is equal to 0. And now by the zero product property, we now know that we can split this up, right, into x plus 2 is equal to 0, x minus 2 is equal to 0, and then solving for them, we get x is equal to negative 2, x is equal to positive 2. So our solution set would be plus or minus, sorry, my mistake there, plus or minus 2. And if you wrote it out as, and I'm going to write it in green here, if you wrote it out the longer way as negative 2 or 2, that's totally fine. I just personally save time with plus or minus because, I'm a time saver sometimes. Not all the time, only sometimes. So this works out for me. And if you wrote negative 2 or 2, that's totally acceptable as well. But yeah, so you guys can easily solve this now, right? Because we have that difference of squares in our head. We have one square here, we have another square here, and we have the difference, which now we know difference of squares, right? Okay, so taking that concept, we can actually apply it to numbers that aren't necessarily perfect squares. Now, I kind of lied to you. It was just a little white lie in the very beginning to try to get you guys in the habit of recognizing difference of squares. I said, yep, just this applies to, perfect squares, right? When I told you guys about a squared minus b squared is equal to the a plus b times the a minus b, I said, yep, this is going to work for specifically squares, perfect squares. Well, as it turns out, that's not entirely accurate because we can apply it to numbers that aren't perfect squares, as long as one of them is. So what do I mean by that? Well, let's go ahead and talk about, we just did x squared minus 4 is equal to 0. What happens if we have x squared minus 3 is equal to 0? And we say, this looks very similar, right? We have x squared, that's a square. We have a difference, right? We have subtraction, but we have a 3. And we say to ourselves, is 3 a perfect square? Technically, yes. Technically, any of our integers, or well, I should be more specific, any of our natural numbers, when there's, subtraction being in there, we can go ahead and collapse that as a perfect square because 3 is the same thing as square root of 3 squared, right? So this is basically saying that 3 is a perfect square. It's just the perfect square of the square root of 3. So I can really just rewrite this as x squared minus, and then the quantity of square root of 3 squared, right? And now we know that if we went backwards, right, if we went back up the board, and we say we could simplify that, right? Square root of 3 squared, we know that those would cancel, and we would get 3. but we're trying to make it so that 3 is a perfect square. We're trying to like break the rules a little bit here. And so what we're doing is we're saying, oh, well, now it works, right? Now we have a square here, we have a square here, and we have a difference. Those were our 3 criteria, right? That's exactly what we needed. So now we're just going to plug in the square root of 3 to, wherever we for our b term. So again, a squared minus b squared is going to give us a minus b times a plus b, or other way around. So we're going to have x plus the square root of 3 times x minus the square root of 3 is equal to 0. And now this really shouldn't seem too far-fetched, right? Because when we did, and I'll draw it over here, when we had the x squared minus 4 is equal to 0, yeah, you guys probably immediately thought, oh, x plus 2 and x minus 2 is equal to 0, right? But what is 2 when compared to 4? Well, 2 is really just the square root of 4, right? So this is really just x plus the square root of 4 times x minus the square root of 4 is equal to 0. In this case, it would work out because you can simplify the 4, right? So it looks a lot cleaner. You can simplify the square root of 4 to be 2, and now you would just have x plus 2 times x minus 2 is equal to 0, like we know and love, right? That all, meshes really well. But here we can't really simplify the square root of 3. It just is the square root of 3, and that's just something that we have to live with. It looks wrong. It may look unclean, but again, the square root of 3 squared is 3. So realistically, this is totally fine. And now all we have left to do is the zero product property, right? We're just going to split this up into its 2 individual pieces. So we have x plus the square root of 3 is equal to 0. And then x minus the square root of 3 is equal to 0. And now all we have left to do is go ahead and subtract or add, based on what the sign is. So we have x is equal to the negative square root of 3, and x is equal to the positive square root of 3, which means our solution set is x is equal to, and then squiggle, because, it's getting late and curly braces are no longer my thing, plus or minus the square root of 3. And that's it, right? And now what you could do is, again, go ahead and check this. If you really think that it's, it doesn't make sense, if this really is not intuitive to you, check your answers. See what you come up with. I'll do one with you, right? So let's go ahead and do the negative square root of 3, because that might not seem, exactly counterintuitive. Or I'm sorry, intuitive. So if we have x squared, and I'll write check here. That's a k. It's pretending to be a k. X squared minus 3 is equal to 0. And we plug in square root of 3 for our x, right? So we have square root of 3, and it was the negative one that we wanted to check, right? So negative square root of 3 squared minus 3 is equal to 0. Okay. Well, remember, whenever we have a negative number being squared, it's a negative number times a negative number, right? So the negatives are just going to fall out anyway. We're just going to end up with a positive number. So we can basically just ignore the negative sign. It's going to end up being the same exact thing. So now we just have to consider, well, wait, what is the square root of 3 squared? Well, we all know that as long as the index matches, the exponent and the square root are now going, or the exponent and the root are now going to cancel, right? So the square root and the square are just going to cancel, and we just get 3 minus 3 is equal to 0. Yay, it works. And we're done, right? We've now checked, well, technically we've only checked one of the solutions, but, square root of 3 would be trivial. It'd be following the same exact procedure. So it might seem wrong that you can factor or break apart, the 3 into the square root of 3 squared, but this is, one other method that we have at our disposal. Now, there is another way that you can apply this quote unquote square root method. And so we're going to still start with x squared minus 3 is equal to 0. And now, right now, it is in standard form, right? Because we have an x squared and then whatever other stuff is on one side, and we have 0 on the right side, right? Well, when you guys had something to the effect of 2x is equal to 4, what did you do? You looked at what operation was tied to your variable, and then you undid that operation, right? So you undid the operation of multiplication, which is, the 2 times the x. So you did division, right? So then you would divide by 2, right? And so you would end up with x is equal to 2, right? So let's go ahead and let's put 3 back on the other side. Let's say, okay, we're going to add 3 to both sides. So we have x squared is equal to 3, okay? And now we look at the operation tied to our variable, and the operation is a square. So to undo a square, we are just going to take the square root. And remember, whatever we do to one side, we also have to do to the other. So we take the square root as well on the other side, and we get x is equal to, and now here's the trick. This is the problem that 90% of students will forget, okay? So don't be in that 90%. When you take the square root, remember what I told you about principal roots, but the exception is when you're solving for a variable, right? When you're solving for a variable, you need to include both of the possible signs that can arise from taking a square root. So we take the square root of square root of 3. We can't really simplify that, so it's still just square root of 3, but it's plus or minus square root of 3, because again, when you take the square root of a number, or when you take any even root of a number, you will always end up with plus or minus, right? You take the square root of 4, and technically there's two solutions. There's, positive 2, and there's also negative 2. Same idea here. You take the square root of 3, you're still going to end up with plus or minus square root of 3. Okay, so then you would end up with this, and hey, this looks exactly like the solution set that we had before, plus or minus square root of 3. Okay, so you can do this in either way. You can do it the factoring way, or you can move the number back over to the other side and undo the exponent with a square root. Just make sure that if you do it in this way, the way that I just showed you, that you add the plus or minus, at the end for your final step, just to make sure that you're covering your bases and you're getting all of the possible solutions. Okay, so I know that was quite a bit. Let's work through a couple other things here. So let's say we have x minus 4 squared minus 7 is equal to 0. Okay, so your intuition might say, all right, well, what I want to do is I want to expand the x minus 4 squared. And then by expanding the x minus 4 squared, I will then, subtract whatever my constant is with that negative 7. And then hopefully I can factor it again. And then by factoring it again, I can then go ahead and do the zero product property, right? So I want to show you guys that there are some cases where that won't work. And this is one of those cases. And then I want to show you how to apply the difference of squares formula to this, or our square root process, right? And then hopefully it'll make a little more sense to you, right? So by expanding the x minus 4 squared, we get, and again, hopefully you guys remember that when you have something in the form of a minus b squared, you get a squared minus 2ab, that's a b, ab plus b squared, right? The sign of the 2ab will always match the sign that's inside that, the a, either a minus b or a plus b. So that sign will stay the same, but you're always going to have a positive a squared and a positive b squared. So that's exactly what I'm going to do. I'm just going to plug this into my blueprint. Feel free to FOIL this out if it's faster or easier for you to understand. I'm just going to do it this way. So we have x squared, and then we're going to have minus 2 times x times 4, right? And then we're going to have the 4 squared, so plus 4 squared, and 4 squared is 16. And we just bring down that minus 7, right? Okay, so now simplifying this, we have x squared minus 2 times 4 is 8 times the x, that hasn't changed. And then 16 minus 7 gives us a plus 9 is equal to 0. Okay, and now you look at this and you say, great, now I just want to factor this, and if I factor this, then I will be done, right? And then, great, we're good to go. So when you try to factor this, you're looking at factors of 9, and factors of positive 9 are going to be as follows. You have 1 and 9, either, and the signs are going to match, right, because we have a positive 9 here. So either plus 1 and plus 9 or minus 1 and minus 9, and then 3 and 3, right? And then still plus or minus. And you say to yourself, wait, 3 and 3 aren't going to work, right? Because if we add a positive 3 and a positive 3, we should end up with a positive 6. We have a negative 8, so that's out. Negative 3 should give us a negative 6. Still not working, right? So that's out. And then you say, wait, hold on, plus 1 and plus 9 gives us a 10, and that's not what we're looking for. And minus 1 and minus 9 gives us a negative 10, and that's still not what we're looking for. So by our traditional factoring method, we can't do this. It's not going to work out by one of the methods that we know. So we have to scrap this. We have to say, nope, this is not the way. This is not going to work. Let's try something else. So, and oh, can we scroll? There we go, tablet. Good job, buddy. Okay, so that's not going to work. But what is going to work is a couple different things, right? So let's go ahead and try difference of squares. So we already just talked about, and I'm going to erase this and put up difference of squares. Hopefully we all still remember, right? Difference of squares, especially because we just talked about it. A squared minus b squared is equal to a plus b times a minus b, right? That's what we're trying to do. That's what we're trying to accomplish here with our squares method. So we say, oh, well, we have a square. Great. And we have a difference. Okay, two of our criteria are met, right? And really, what is 7 except the square root of 7 squared, right? The square root of 7 squared is just 7. So I can just replace 7 with the square root of 7 squared. So that's what I'm going to do. I'm going to say, okay, I have x minus 4 squared minus the square root of 7 squared is equal to 0. And now you say, oh, great, perfect. We have two squares and we have the difference of them. We have difference of squares. And now this is the trick. This is the tricky part that, might not make sense. This entire term is going to be your a. This piece here, the square root of 7, is going to be your b. So you just need to plug it into our difference of squares formula, a plus b times a minus b, and see what you come out with, right? So if we have a plus b, that's going to be our first part. The entire a is x minus 4, and then plus the square root of 7. And now we have the a minus b part. So a is still x minus 4 minus the square root of 7, right? So this here is our a, this here is our b, this here is still our a, this here is still our b, and notice that we have a plus b and a minus b, right? So we've now successfully factored this into difference of squares formula, which means that we can now go ahead and solve this, right? It's factored. So we have something times something. So we can now put this by the zero product property and say, okay, we're going to split this up. We now have x minus 4 plus square root of 7 is equal to 0, and x minus 4 minus square root of 7 is equal to 0. And now we're just basically isolating our variable just like we did with linear equations. So to do so, we now have x. I'm going to add the 4 and subtract the square root of 7. So adding the 4 to both sides, we have a positive 4 here minus the square root of 7, right? And then on the other side, we're adding the 4 still, but we're also adding the square root of 7. Right, because they're both negative. So isolating our variable here, we add the 4 and we also add the square root of 7 to both sides. And now we see, oh, these look very similar. Our solution set is x is equal to 4 plus or minus square root of 7, right? The only difference between the two solutions is, the sign between them. And square root of 7, you might be wondering, what is that number? Well, it's somewhere between the square root of 4 and the square root of 9. You know that the square root of 4 is 2. The square root of 9 is 3. So it's somewhere between 2 and 3, and it leans a little closer to 3, I believe. I think it's like 2.5 something. I'm not sure. But it doesn't necessarily matter, right? Essentially, all you're saying is you have 4 plus this, whatever this garbage number is, and 4 minus whatever this garbage number is. And you can actually go ahead and check it by plugging in these two different solutions. You could plug in the 4 minus square root of 7. You can also plug in the 4 plus square root of 7 and into your x way back up here, and it will work out. I promise you that by doing the check, you will end up with, 0 is equal to 0. So that's one way to do it by the square root method. And the last way to do it by the square root method is the way that I said, you're kind of breaking the standard notation, right? The standard notation is where you have a 0 on one of the sides, right? So if we did have that x minus 4 squared minus 7 is equal to 0, breaking that standard convention of the 0 on the, by itself on the right side. Well, if I add 7 to both sides, we're left with x minus 4 squared is equal to 7. And what is the main operation that's being tied to my variable, the one that I have to deal with immediately? It's the exponent, right? I have that exponent there of 2. To undo the exponent of 2, we would take the square root of both sides. So taking the square root of both sides, this would cancel with our exponent. And we're left with x minus 4 is equal to, and now again, don't be part of that 90% of students, right? When you take the square root of 7, whether or not you can simplify square root of 7 doesn't necessarily matter here. What matters is that you put the plus or minus. The plus or minus is very important because you're including both of the possible values of taking the square root of 7. Right? So now all we have to do is just add 4 to both sides. So adding 4 to both sides, we get x is equal to 4 plus or minus the square root of 7. And you're like, oh yeah, that's exactly what we had before by factoring by difference of squares. So that's it. Okay. So I know that was quite a bit. What I want you guys to do is I want you guys to work on one last classwork assignment, and then we'll call it a wrap here. So we have x minus 3 squared minus 4 is equal to 0. So what I'm going to do real quick is I'm going to show that this is one of the times where you can factor it if you expand and then you subtract the 4 and then you factor. And then once I'm done with that, what I want you guys to do is try doing it by the square root method, either one, whether you add the 4 to the other side or by difference of squares. Difference of squares is probably a little more helpful, but adding the 4 to both sides is also probably makes a little more intuitive sense. So here's how we would factor it if we wanted to expand first, right? So x minus 3 squared, and again, I'm just going by that a minus b squared blueprint, right? So we have x squared minus 6x, because it's 2 times 3 times x, so 6x, and then plus 9, which is the 3 squared, minus 4 is equal to 0. We would simplify that, x squared minus 6x, 9 minus 4 gives us a plus 5 is equal to 0. And now we just look at, because we don't have a coefficient for x squared, we just have to look at our c, and the only factor pairs, I should say, of 5 are plus or minus 1, plus or minus 5. Obviously, we want it to be negatives because we have a negative 6. That's what we're trying to get. So negative 1 plus a negative 5 is the same thing as negative 1 minus 5, which, yay, gives us negative 6, which is what we want, right? So then we just go back and we say, great, x minus 1 times x minus 5 is equal to 0. Zero product property says, great, x minus 1 is equal to 0. X minus 5 is equal to 0. And then solving, you just add each respective number. So we get x is equal to 1, x is equal to 5. So our solution set is the 1, the 5, and we're done, right? So that is one way to solve this. And now go ahead, try your classwork assignment of doing this by one of the square root methods and see that you should also end up with 1, 5. And I'm going to go ahead and clear this and rewrite all of this again. Okay, so hopefully that wasn't too bad for you guys. So what I'm going to do is I'm going to do the difference of squares way. The other way is you're adding 4. So I'm just going to talk through the steps. You would add 4 to both sides. So that would leave you on the left side with x minus 3 squared is equal to positive 4. You take the square root of both sides. So that way you undo that square that's being applied to the x minus 3. So you would be left with this. You'd be left with x minus 3 is equal to positive, plus or minus the square root of 4, which we know is 2. And then by doing so, we would add 3, and then we would get x is equal to 3 plus or minus 2, which would give you 2 different solutions, right? Which would give you x is equal to either, if it's 3 plus 2, we would get 5. And if it was 3 minus 2, we would get 1, right? So 1, 5, which is exactly what we desired. That's what we wanted to get. So the difference of squares way is as follows. So what I want to do is I want to say, great, this entire piece here is my A. This entire piece here is my B, because 4 is really the same thing as 2 squared, right? Or, the square root of 2 squared, square root of 4 squared. My mistake. Sorry, guys. I know I'm talking really fast right now. So square root of 4 squared is equal to 4, right? And that's exactly what I'm going to plug in. So I'm going to put a plus b times a minus b. So a is my x minus 3 plus the square root of 4. And then a minus b, which is x minus 3 minus square root of 4 is equal to 0. And again, we know square root of 4 is just 2, so I'm going to break that down. We have x minus 3 plus 2 and x minus 3 minus 2 is equal to 0. And by the zero product property, we can break this up. We have, and I'm also going to simplify the numbers together while I do this. So x minus 3 plus 2 is the same thing as x minus 1 is equal to 0. And on the other side, x minus 3 minus 2 is equal to 0 is x minus 5 is equal to 0. And now we just add, right? We add 1 and then we add 5, to our each respective equations. And that gives us x is equal to 1, x is equal to 5. And by the third time that we're doing this, the third different way that we've done this now, x is equal to the solution set of 1 and 5. And now we've shown, again, 3 separate ways that this all works out, right? Okay. So that's it. That's it for this lecture. It was about 55 minutes, I think, which is pretty on par for what I think I've been doing so far. So again, apologies, but definitely still, I'm getting better, right? I minus 5 minutes off. So we're doing good. We'll get down there. So yeah, let me know if you guys have any questions. Try the homework. Classwork assignment will be up to accompany this. And yeah, that's about it. So enjoy the rest of your night, guys, and we're going to call it a wrap here. Thanks. Bye.